Welcome back. This is video number 1B, continuing our discussion of section 3.1. Now we're going to be doing objective number 5, and then we will finish off with objective number 6. So objective number 5 is finding x and y intercepts. So you can see on slide number 6, 7, and 8, we have the information for objective 5 and objective number 6. So let's begin with 5. So we're talking about graphing still. Our next way to graph is using x and y intercepts. Objective 4 discusses graphing lines using xy tables. Now we're going to graph using x and y intercepts. So what is an x and y intercept? Well, if you look on slide number 7, the x-intercept is where the point, or where the line intersects the x-axis. It tends to be written as the coordinate point of the number, comma, 0. The y-intercept is the point where the line intersects the y-axis. It's written as, in parentheses, 0, comma, the y value. So again, it's where the line crosses the x or y axis. X-intercept crosses the x-axis, y-intercept crosses the y-axis. And on page 165 of the textbook, you can find the steps for finding the intercepts. So the way you find the intercepts is you actually are going to kind of create an xy table. You're always going to have the zeros though. You're going to have x equals 0 and y equals 0. Those are the only two coordinates that we're going to plot. So if you see a question on the exam, it says, graph using x and y intercepts. This is the only way I will accept the problem. You need to plug in x equals 0, solve for y, then you have your x-intercept, your y-intercept coordinate. Then you plug in y equals 0. You get your x coordinate. That then is your x-intercept. So let's go through the steps. Alrighty. So first thing I'm going to do for number 33, which is 2x plus 3y equals 12. I'm going to plug in x equals 0. Okay. This drops out. 3y equals 12. Divide both sides by 3. I get y equals 4. Now I said there's you can use the xy tables. I can just plot. I can just plug the number into the xy table. I will accept that as an answer. If you don't want to use xy tables, you have to write your answer as a coordinate point. At y equals 4 is not a y-intercept. Your y-intercept would have to be written as 0, comma, 4. I must see either way. Either written as a coordinate point or written in your xy tables. I will accept either way on an exam. Okay, so there we found our y-intercept. Let's go in now and find our x-intercept. So to solve for our x-intercept, y equals 0. So I plug in 0 for y. So now this drops out. 2x equals 12, divide by 2. I get x equals 6. Again, this is not my x-intercept. My x-intercept would have to be written either as the xy table or written as a coordinate point. Now 6, comma, 0. And here we have our x-intercept. So now either way, I've solved for my intercepts. I have them. Now let's graph them on the graph. So I'm only going to plot those 2 points, only the x and y intercepts. So x equals 0, y equals positive 4, x equals 6, y equals 0. So there's our 2 intercepts. I connect them with my straight edge. And I am done with number 33. And this is all the work I would expect to see on an exam. Either solving using x and y tables, but always showing your work out, or showing your work and then writing your actual coordinate points for the x and y intercept. And that's our first example. Let's try number 35 now. 35 is x minus 3y equals 6. So I'm going to go through the same steps. I'm going to show you with x and y tables and with coordinate points. So first, let's find our y-intercept. So I plug in x equals 0. So this drops. Negative 3y equals 6. Divide both sides by negative 3. Y equals negative 2. So my coordinate point would be 0, comma, negative 2. And that's my y-intercept. Now let's do our x-intercept. So y equals 0. So x minus 3 times 0 equals 6. This just drops out to 0. X equals 6. So that corner point is 6, 0 again. Put that in my xy table. Okay, now I'm going to plot just these two corner points. So x is 0, y equals negative 2. X is 6, y equals 0. And then I take my straight edge. And I connect the 2 points. So there I did the work for number 35. Again, either do it as XY tables, but you must show this work, or you do it as corner points, but you still have to show your work. Okay. So there's objective number 5. Our last objective, objective number 6, is titled Recognize equations of horizontal and vertical lines and lines passing through the origin. So a line parallel to the x-axis will not have an x-intercept. So it will simply be written as equation as y equals a number. That number is where it's going through the y-axis. A line parallel to the y-axis will not have a y-intercept. So the equation will be written as x equals a number, x representing where it goes through the x-axis. And this can be found on slide 7 and 8. A horizontal line with the equation y equals 0 is the x-axis. The vertical line with the equation x equals 0 is the y-axis. Look at the caution on page 167. It goes over a few things about vertical and horizontal lines and parallel lines. When lines have both the x and y intercepts equaling 0, the line is passing through the origin. So if you were to solve for your intercepts and you get both 0, 0 for both the x-intercepts and the y-intercept, that means it goes through the origin. The equation will be rewritten from standard form into y equals mx plus b form, which we'll talk about more in section 3.2 in video number 2a and 2b. But the equation is written here simply as y equals m times x, so y equals a number times x. On slide 8, you have a visual of the 3 special graphs going through the origin, vertical line and horizontal line right there on the slide. So let's try the 3 examples found on page 171 and 172. So first we have number 39, y equals 5. Now it says y equals 5, so that means that if I was to use xy tables, which is I would want you to use xy tables for this type of question, no matter what my x value is, y will always equal 5. That's the important point. The x values don't matter. I can pick any arbitrary numbers. I'm going to do 0, 1, 2, and 3. Now I'm going to plot them. X equals 0, y is 5. X equals 1, y is 5. X equals 2, y is 5. X equals 3, y is 5. Okay? Now I need to connect my points with my straight edge. So the equation was y equals 5, which means that it was a horizontal line. There is no x-axis, and it's in the form of y equals a number. The number represents where it is crossing the y-axis. Y equals 5, here's where y equals 5, right on the y-axis. And right here, 0, 5, is your y-intercept. Let's look at number 43. Now 43, I don't have it in the form I want. So I'm going to add both sides by 4. So I rewrite the equation as x equals positive 4. So just like with number 39, instead of it being y equals, now I have an x equaling a value. So in my xy table, no matter what, x equals 4. And I'm going to make y 0, 1, 2, and 3 again. Now I'm going to plug these points in to the graph. X equals 4, y equals 0. X equals 4, y equals 1. X equals 4, y equals 2. X equals 4, y equals 3. I'll take my straight edge. I connect those points. I have a vertical line, no y-axis. It's of the form x equals a number, where the number is telling you where it's going through the x-axis. And 4, 0, right here is your x-intercept. Beautiful. So you have horizontal and vertical. Now let's try one that's going through the origin. So x plus 5y equals 0. So I am going to start by plugging in the intercepts. So I plug in x equals 0. So 0 plus 5y equals 0. 5y equals 0. Divide everything by 5. I get y equals 0. Okay, so far I do not have an x-intercept. Now I'm going to plug in y equals 0. That drops out. X equals 0. So because I got 0, 0, and 0, 0, that means I have no x or y intercepts. It's going to go through the origin. Now I actually don't need this fourth coordinate point, so let's just cross that off. Now for the last point, another line that I need to have another point to connect my graph. And in order to do that, the textbook explains rewriting the number as y equals mxb, using the intercepts, and then another point. The other point can be any other number for x or y, where you would solve for the opposite variable. So what I'm going to do is I'm going to plug in x equals 5 into my xy table. So that's what I'm going to plug into my equation. Now I'm going to see what happens here. So if x equals 5, I get 5 plus 5y equals 0. Subtract 5 on both sides. 5y equals negative 5. Divide by 5. Y equals negative 1. So now I do have a second coordinate point. And I can come over here. X equals 5. Y equals negative 1. And I now have a second point that I can use to connect the line with my using my straight edge. So there I have one that's going through the origin. Now the textbook also explained how to rewrite it into y equals plus mxb form, y equals nx form. I would subtract the x on both sides. 5y equals negative x, divide by 5, which means y equals negative 1/5 x, which is the same as saying y equals m times times x. I have y equals a number times x, and that would be the rewritten equation for this line from standard form to y equals mx form. If it's in that form, there's no plus or minus a number at the end. It must go through the origin. And the process you can go through then would be to use the xy tables, do x equals 0, y equals 0, and then come up with an arbitrary second number either for x or y. Try to find one that you think would solve where both would be a whole number, and that's the best way I can say to solve for these types of questions. You're going to have some of these on my math lab. You might have one on your exam. Okay, so that brings us to the end of objective number 6 and all of our notes for 3.1. So at this point, I would say review this once more if you need to. Take the time to try the questions a second time. Review the problems, review the notes, and when I see you guys on Wednesday, we're going to pick up with 3.3. And please go on to 3.2, watch video number 2A and 2B, and after you watch those videos, we'll definitely have a good understanding of 3.1 and 3.2, and on Wednesday we can start with 3.3. Have a good day.